Morning, kiddos. Yesterday, for some reason, I had a so-called brain fart. I don't know why it just wouldn't register. I'm human, so please forgive me for being human. Uh, for some reason, for the life of me, I could not divide very well yesterday. So today, I'm refreshed, and I'm going to go over how to convert from binary to sorry. There you go again. It's flopped. I want to go from base 10 to base 2. All right? And you can use this method pretty much with all of them. Okay? So, what I'm going to do is I'm going to say pick a base 10 value. So 360 like I was doing yesterday. And what we're going to do is we're going to divide 2 of the whole amount. Normally you would do division like this. 2 going 3 one time, which would be 2, and then 1 and 16. 2 going 16 8 times, right? And that'd be 16, and you have nothing left over. And 2 going to 0 0 times, right? That would be 180. And that would with this step, but it's a little different when we're converting. We have to do this part in a whole. So 2 will go 360 180 times. So when we multiply this, that comes out exactly 360. So that gives us a remainder of 0. And we do each one of these step by step. So 2 will go into 180 90 times. And 2 times 90 is 180, so there's a 0 remainder. So again, we just keep going until we get down to 1. So 2 will go into 90 how many times? 45 times with a remainder of 0. And keep going. 2 will go into 45 how many times? 22 times with a remainder of 1. Remainder of 1, right? 2 will go into 22 times 11 times with a remainder of 0, right? 22, right? 2 times 11 is 22. All right. I don't know why I got hung up on that. 2 will go in 11 5 times with a remainder of 1. 2 will go into 5 2 times with the remainder of 1. 2 will go into 2 1 time with a remainder of 0. So now, if we take this 1, 0, 1, 1, 0, 1, 0, 0, 0. Once you stop when you get to 1, okay? So what place value? 1, 2, 4, 8, 16, 32, 64, 128, 256. All right, we have 256, 64, 32, and 8. And everything that's 0, we don't add. We only add in all the ones. So 256 and 64 is what? 6 and 4 is 10, carry to 1. 11 and 2 is 12, carry to 1. So we're at 320. 2 and 0 is 2. 3 and 2 is 5. And bring down to 3. And then we add 8 and 2 is 10. Carry to 1, 6, and 3. Our answer should be exactly that. So this is our binary number for 360 in base 10. So I don't know what was going on yesterday, but again, I'm sorry. I got a lot on my plate. I'm human. I couldn't even think about I couldn't even remember the addition with the XOR. That still bothers me there because that one should stick in my head because that's one that just doesn't often happen. So let's do it again. Let's pick a number. Let's go 31 and we want to make it into octal. So how many times will 8 go into 31? So what? 5 times 8 is 40, right? 4 times 8 is 28. You think that would work? 4 times? So, so 8 will go into 31 what? 4 times, which is 32, so that actually won't work. So it's 3 times, right? I'm forgetting my multiplications. So 8 will go into 31 3 times, which is what? 24, 27, 24, right? Right? 24. 24 from 31 is what? So we go 31. That makes 11, right? So 7 and 4 is 11. So we got a remainder of 7. 8 will go into 3 how many times? Right? 8 will go in 3. Oh my God, just like that. My brain is bad. Let me cut that section.